Hello and welcome to Form. Now, the structure of the atom and the periodic table. We are going to go back to the roots of chemistry, the structure of the atom. What do you think an atom is? Imagine this. What if you take a piece of wood or a piece of iron metal and you zoom in using a very powerful electronic microscope up to 100 billion times? What do you think you would see? Would the structure you see for wood be the same as the structure you see for iron, metal? Everything in this world exists because of atoms. They are so tiny, yet they are the most fundamental particles of each and every matter in the world, including living organisms. However, we are going to learn more about these atoms as we go on. Now, the periodic table, on the other hand, is like what you see on the left-hand side of the screen. It is the arrangement of different elements depending on their sizes. Scientists have come up with different models of the periodic table, but eventually the agreed upon periodic table is something like what you see on the picture. To start off, let us go back a few thousands years back. Back in the early ancient Greece, a Greek philosopher came up with the name atom. Atom is derived from a Greek word atomos, which means indivisible. The Greek philosopher came up with the idea that everything is composed of atoms and the void. The void is just an empty space. Now, let us get back to the 21st century. Imagine this: taking a cube and cutting it with a knife along these two lines. Equally, we end up with 4 equal cubes like this. Then imagine taking one of those cubes and cutting it the same way again with a knife. What do we end up with? 4 smaller cubes. Then take one and cut it again into 4 smaller cubes. And we'll have even tinier cubes. Imagine repeating this process over and over and over. What do you think we could end up with? Could this process continue without end? Or could it reach a point that we could not split the cube any further? This was the question that was in the mind of the Greek philosopher Democritus. And that is why he said that everything is made up of an atom, which he described to be very small or tiny. For many centuries and millennia, scientists and philosophers have not agreed upon the existence or the nature of atoms. It was until the 19th century that we had a breakthrough. Fast forward to the 19th century, and we had a major scientific breakthrough by a scientist known as John Dalton. According to John Dalton, he came up with his model of the atom, stating that matter is composed of very small, indivisible particles called atoms. He also noted that atoms can neither be created nor destroyed. Also, all atoms of an element are alike in terms of properties and their size. However, atoms of different elements have different sizes and masses. To him, an atom was a spherical ball like you see here that could neither be divided into any smaller particles. Atoms could also combine with each other to form compound atoms. However, a few years later, more scientific research through the scientist known as J. Thomson discovered some flaws or errors in Dalton's model of the atom. Using scientific experiments in physics that used the cathode ray, he discovered that atoms contain positive and negatively charged particles. He suggested that the positively charged particles were surrounded by negatively charged electrons, as shown in his model of the atom. He called the negatively charged particles electrons. Further research in 1911 by a scientist known as Rutherford came up with another model of the atom that was even more detailed than the previous models. Rutherford suggested that an atom contains a center known as the nucleus, which consists of protons and neutrons. The protons were positively charged, while the neutrons did not have any charge. Surrounding the nucleus was an empty space that was filled with fast-moving particles known as electrons. Imagine the solar system. The sun is at the center and the planets revolve around the sun. Basically, Rutherford thought of an atom in such a manner, but this time the atoms moved in orbits that were not flat but made a sphere around the nucleus. So, from these models, which one do you think best describes an atom? However, from these Rutherford's model, present and current science was born. We are going to represent an atom based on Rutherford's model, but instead of having the electrons moving fast around the nucleus, we're just going to imagine them stationary. so that we could easily understand how atoms behave.